let's look at number 11. 11A. The enthalpy of vaporization of chloroform is 29.4 kilojoules per mole at the normal boiling point. It's also given. Asking us to find the entropy of vaporization for chloroform clearly at this temperature. So this is a phase change, and we want to know the entropy change of the surroundings corresponding. So let's transpose this into a more tidy fashion. So here we are, number 11 in this series, a really good review series of these exercises in this chapter. So chloroform, CHCl3, we know that delta H of vaporization, 29.4 kilojoules per mole, and the temperature for boiling, I usually do this, normal boiling point, is 334.88 Kelvin, and we want to know what is the entropy of vaporization. Well, for a phase change, remember, it's still always the same starting point. And we know that for a phase change, which clearly this is, it's a constant temperature and a constant pressure, because things will change, will vaporize at that temperature and at that pressure. So in this case, at the normal boiling point. So normal, constant pressure, 1 atmosphere, and this is our boiling point. So this is, in fact, a dQp, which we know is a dH, and so if I integrate that, I see that this is delta H over T, and you'll see from your notes that we called that a transition for a phase transition. And so here what we have specifically in some textbooks and yours right now, and this edition likes to do this. We put the phase transition there. Wrong letter, sorry, it's entropy. So whether you write it like that or you write it like that, I know what you mean. And I'll just put in the values. So I have 29,400 joules per mole divided by the temperature. So it will be joule per mole Kelvin, 29400 divided by 334.88. And the answer is 87.79 joule per mole Kelvin. In 3 sig figs, 87.8. Positive value makes sense, right? Sorry, I should look up. Yeah, positive value makes sense. It's vaporization, so clearly from a liquid to the vapor, we have a large jump in disorder. Also, does this remind you of anything? Troughton's rule? Yeah, about, wasn't it estimated to be about 85, the entropy for organic liquids? About 85. So this one a little bit more, but when you think about it, there's chloroform, some strong, maybe, different interactions there. Is it a polar molecule? CHCl3. If you think of its Lewis structure. Yeah. So it's not completely nonpolar, so a little bit off the 85. But anyway, that's that. Also asking about delta S for the surroundings. But as a phase transition, this is an equilibrium description. So delta S total is 0, and so delta S of the surroundings would be the negative value of what we just found for the system. Yeah, because vaporization occurs reversibly, and so delta S total is 0. And so that's my reasoning behind delta S of the surroundings being this number but negative. So that's number 11, and we're only past 5 minutes, so why don't we do number 12? Can we do number 12? Let me have a look at number 12. Oh no, that's a long one, so let's stop it there.